pretty much zero, very close to zero. And the idea again is if you can work elsewhere and have a higher return on your labor input, then that is what you ought to be doing. We need to focus then on the marginal product of labor and the average product of labor. The key idea here is that if you have more workers, more people, the worker right here, L2, this last worker is contributing nothing. The marginal product of labor is zero, so she's contributing nothing to the overall output. And actually what happens is that if you keep hiring workers beyond L2, you're going to end up with the overall output going down. The overall output will be measured then by the quantity of labor and the average product. So this rectangular area here is your total output. And I'm arguing that then if you were to try and increase the number of workers any further, the total output would go down. In Lewis's thinking, and Sir Arthur Lewis is the only Nobel Prize winner I've actually interacted with, he was not very mathematical, and he laments that, but he actually thought of the marginal product being zero. And in this analysis, I have the marginal product becoming negative. It's a stronger point to say that the marginal is close to zero, but the mathematics will bear this out as being an equally viable alternative way of expressing Lewis's argument. The key point I want to make here is that if you hire the worker who is numbered L2 and he contributes zero additional output, then what happens is that he actually takes away from the average that everybody else gets, and you can see that the wage rate would keep falling if you continue to hire workers. Even at a high point, such as maybe L1, number of workers, with a high average product right about here, or high wage, every worker after that would pull the average down, and the marginal would fall even faster. Those of you who are familiar with marginal revenue and demand understand that the marginal revenue curve heads downward twice as fast, or we say this is the analogous concept, and the marginal productivity is declining very fast. The average product is also falling, but the average product is still positive even after the marginal product becomes negative. So the point here, I'm trying to focus on this worker. If the worker numbered L2 is hired and contributes nothing, but still gets paid a wage based on the principle of sharing the output equally amongst everyone, then that worker's contribution is zero, but he gets a return on that particular effort. Let me move to the next page. Here's a quantitative analysis on the Lewis manufacturing sector. They're both going to be increasing at a decreasing rate, so the output will keep increasing, but the marginal product is decreasing. And you would recognize, because it's squared with a minus in front of the squared term, that you would actually have a diminishing marginal product. The mathematics of that formula tell you the marginal product is diminishing. If you have 20 workers, the question for you is to find out the largest amount of output, and we're multiplying the quantities by 1 to get the overall GDP. So how much is the maximum GDP the country can have? And what you can do is start by allocating all 20 workers to one sector, 0 to the other sector, and then try to move them 19, 1, 18, 2, etc. until you find the highest quantity of output. I actually use a spreadsheet to solve this particular problem, and here are the data based on the spreadsheet. Here's the production function, the quantity of labor and the quantity of output from 0 workers up to 20 workers. I hope you can see that. And this is what the production function looks like in the agricultural sector. So 20 workers would produce 160 units of output. What is the maximum quantity of output or revenue or GDP, all being the same thing because the prices are 1 and just adding the value of the output in the two sectors. So if I have all 20 workers in agriculture, the GDP would be 160. If all 20 workers were in manufacturing, the GDP would be 160. But if I were to assign 19 workers to agriculture and the other worker to manufacturing, I have 159.6 plus 9.9, which is 169.5. So you see I can increase the overall output by allocating the workers between the two sectors. That should be pretty obvious to you. What I've done in this third analysis is I've numbered the workers so that the sum is always going to be 20. And I tell you the output, and I multiply by 1 to get the GDP. So what I just said was when the workers are all assigned to the manufacturing sector, the GDP is 160. When 19 workers are assigned to the manufacturing sector and 1 to the agricultural sector, we get 15.6 plus 153.9, which is a total of 169.5 as our GDP. And by allocating the workers between these two sectors, you can run down the table here, and you're looking for the highest number when you sum the GDP from the two sectors. And it looks as though if we allocate the workers 10 to agriculture and 10 to manufacturing, we get 210 as our GDP, and that's higher than any other allocation. Notice the 911 and 119 will both be lower, so that means that we have found the maximum level of GDP when we allocate the workers 10 and 10. There's no magic to the 10 and 10. Allocating the workers 50-50 percentage-wise will not necessarily give you the best outcome. But here is Lewis's main idea. Lewis argued that the rural sector was allocating the output equally amongst its workers, so it was using the principle of average product to allocate the output, whereas the urban manufacturing sector, or the new capitalist sector that was developing in the urban area, was using the marginal product principle. So by doing so, we would be allocating workers between these two sectors, rural and urban, so that a worker will see the same wage in both sectors, all else remaining equal, and the workers would then assign themselves in such a way that it would be the same amount of return. So for example, if there were too many workers in the agricultural sector, for example, suppose my pointer here is showing you the allocation of workers. I have an additional number of workers in agriculture, and a worker in the agricultural sector would say, why should I accept a low wage when I can migrate to the other sector and earn a high wage? When that is the level of allocation right about here. So we would have the workers reassigning themselves, and my pointer is going to drift to the left until the wage rates equalize. Lewis's argument, though, we're still focused on the main point he was making, is that the rural sector is using the principle of average product to allocate its output, or to pay wages, while the urban sector is using the principle of marginal product, and you get the allocation such as you see here at L1. Everybody's making the same wage, but the rural sector is using a principle that will not maximize the output. Two marginal products equate at L star. This is actually the highest level of output that you can obtain when the allocation is at L star. You need to cut back on the number of workers in agriculture even further and let these individuals migrate to the manufacturing sector. So the manufacturing sector will hire more workers. In the process, it will bring the wage rate down. And when you pay in the rural sector based on marginal product, the marginal product may have gone as low as 0, but as you walk backwards here, you can see that they're going to make less than they would at the average product wage rate, but that would actually maximize the output. So here are the data again, and I've calculated the marginal product. So if you went down the first two columns, you would see as the number of workers increases that the marginal product is going to diminish. And I'm going to start the manufacture for the marginal product to be equal. So in the fifth column, I'm subtracting the marginal product of agriculture minus the marginal product of manufacturing until I get a number as close to 0 as I can. And right about here, you'll notice the marginal product difference is 0.3, and the number of workers are allocated 10 and 10. And that was the point where we met at 210. So by equating marginal products, a principle that you should have heard before, we maximize whatever the goal happens to be. In this case, it is maximize the GDP, or the marginal returns being equal here will maximize the revenues in the various sectors. I have my two marginal product curves plotted on the right hand side, or get the two different marginal products to be as close to 0 in terms of their difference. So I want the difference between the marginal product. I'm measuring the marginal product of manufacturing starting at this axis, at this point, and increasing labor going this way, and therefore my marginal product of labor curve in manufacturing will flip around, because this is my origin for labor in manufacturing. This is my origin for labor in agriculture. Notice that the horizontal length here is going to be the number of workers I have available, and I'm looking for the point where the marginal products of the two sectors equalizes, right about there at 10 workers in each sector, the marginal products are equal, and that will maximize the GDP in the economy. So Lewis was arguing that you need to get the two sectors to use the same principle, equating marginals, and in the process then you would have to reduce the number of workers in the rural sector because the marginal product of labor was pretty much close to zero, and what we needed to do was to bring that marginal product back up. And in order to do that, we had to lay off some of the workers in the rural sector. In the second panel, I'm showing the equating of average product of labor in agriculture with marginal product of labor in manufacturing, which Lewis said is what the economy was doing. It was not maximizing the GDP, and what the economy needed to do was to equate the marginal product of labor in agriculture with marginal product of labor in manufacturing. So instead of operating at this point right here, where the marginal product of labor is actually very low, we needed to move to the point where the two marginal products are equal, and mathematically the equation of the marginal products will maximize the GDP. So the optimal allocation would be to have fewer workers in agriculture and therefore more workers in manufacturing. Sometimes I call that go to the city, young man or young person, so that you can actually do better for yourself. There's a lot to be analyzed behind what I'm saying, because if the rural sector is paying according to average product, the downside of this principle is that you effectively are eating your seed corn. You're distributing all of the output, and therefore there's no likelihood of a reinvestment in the next year. The capitalist principle of equating marginals would then have a situation where we can actually hold back some of the profits, so to speak, and use that to motivate the production in the next particular cycle. So if average product is being used, it allocates all of the output amongst the workers, and if no one has the incentive to reinvest because they figure my investment will benefit others rather than benefit myself solely, then you end up with a situation where the incentives are skewed and we do not have continuous increasing productivity in this particular case. So equating marginals means that there's a capitalist manager who is watching the marginal product and not paying you more than your marginal productivity. In the process, we would have some profits left over, and those profits being reinvested would become the engine of economic growth. The sector that is making the profits, in Lewis's scenario, the urban sector, the urban manufacturing sector, was going to be profitable. That was going to reinvest its profits and grow. But if the agricultural sector could shed some of its workers, then the manufacturing sector would have more workers to work with. But these individuals who are being overpaid to work in agriculture can now go find jobs in manufacturing. And that would actually increase the profitability of the industry, the manufacturing industry, and create even more prospects for jobs, assuming that the profits are reinvested in the operation.